Okay, good morning, class. Let me know if you can hear me. Can you guys hear me? Okay, good. Sorry about the delay. This morning I had technical difficulties. Sometimes that happens, right? You guys know that. You guys are online, so you guys know technical difficulties happen. Okay, let's get right into it. Today, first thing we start with land acknowledgement. We acknowledge we are hosting the lands of the Mississauga of Naushabi, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, so today is Monday, August 12th, day 8. So we have 10 more days left. Tomorrow, there is a test for you guys. Unit 3 test is happening tomorrow. Can I type my email? Okay, the email for me is okay, give me a second, okay? Because we're gonna do different things, okay? So let me tell you the agenda before doing any of that kind of stuff, okay? So there's a test tomorrow. So I want you to listen to what I'm saying. There's a test tomorrow for Unit 3. It's actually Unit 3. Let me fix that. Say Unit. Ooh. Oh, my bad. I'm scrolling all the way down. See what happens when I get distracted? Yeah. So Unit 3 test tomorrow. Application thinking. We're going to be talking about exponential functions, right? So today is the last day of going through exponential functions. Today's the last day. Okay. You have a worksheet 1 and 2 for today, and then you have a quiz for today for the topics that we're talking about, which is going to be graphing exponential functions, transformation of exponential functions. Okay. So today's the last day for that, and there's going to be a quiz for these topics for today. You get 2 chances, like always. There's also a review quiz. The review quiz does not count as for marks, but it's to help you practice questions, overall questions that will be on the test tomorrow. Okay. Now, before I continue, I want to just double check that I can see everything that you guys can see. So I'm going to change it as a student. By the way, whoever asked me about my email is in the course outline, okay? So if you go in Brightspace, the course outline, which I'm not gonna do right now, go in there, you'll see my email, okay? And you're gonna use the Brightspace email. There's 2 emails, use the Brightspace email. Do not email into my regular TSP because I have a whole bunch of emails. The only people that email me in Brightspace are students. So that's why I want you to email me in Brightspace. Use the course outline, go in there, you'll find my email, okay? Hopefully that helps you. Okay, so as a student, I want to see what you guys can see. So I can click on test. It's unavailable. Oh, let me go back. It may be unavailable because it's not tomorrow. Tomorrow at 12:59 a.m. tonight, it will open up. So that's why it's not available. But I just want to double check that before I even. All these things I do at the beginnings, I want to make sure. Okay, before I even go there, let me check the worksheets. Okay, it looks like the worksheets work. Okay, there you go for August 12th, day 8, worksheet 1, worksheet 2, Okay, looks like that works. And then let's check the quiz for today. The quiz for today should work. Yeah, looks like the quiz for today works. Okay. I'm going to click on the practice quiz to see if that one works. Yeah, it works. It tells you right there. You get 3 chances. It does not count for your mark. And I'm just going to do one other thing. I'm going to go back and double check the unit 3 test. Yeah, it's not available until tomorrow. That's why you can't see it. Okay. The other thing I wanted to say for everybody, okay, and maybe it doesn't apply to people that are here. Today is the last day for, like, I have to get your marks in. So tomorrow morning, you're going to see your report card, or you're going to see the mark that goes on your report card, okay? So there's some people, and I'm going to say it again, there's some people who have not handed in the test unit 1, unit 2. I mean, that's going to affect the midterm mark. The midterm mark that you'll see tomorrow is going to be based on everything you did, the quiz, all the quizzes up till today. So you did today quiz, you got to get it done, okay? Because that will be on your midterm mark tomorrow. Yes, your midterm, yes, unit 2 tests will be count. There's a lot of people for whatever reason that did not do unit 2 test or unit 1 test. Give me different reasons, like they're too busy. I'm telling you right now, if you say you're too busy, or I fell asleep, or I was at my friend's house and I got tired, or I was working all day at a full-time job, those are not real reasons. I'm saying again, those are not real reasons to not do a test or a quiz. The only reason to not do a test or a quiz is, like if you're in day school. If you're in day school, what happened? You would be sick. You'd be, go to the doctor's office. When you're at home and you're busy, you're not thinking that you're online. You have to spend 6 to 8 hours a day, Monday to Friday. You cannot spend 6 to 8 hours a day if all of a sudden you're working full time, or you know what, some people are doing three courses online. It doesn't work that way. Okay. So tomorrow you'll see your final mark. Okay, so don't ask me questions that I can't answer right now. Okay. You got to send me emails for that, right? Okay. You need to submit the test in the proper spot. I addressed some of that with some people. So some people submitted it, I fixed it, whatever. I gave you updated marks, but please, you have to remember, when you do the test, you got to submit application with application. Don't put application with communication. Okay. I address that. And you have to learn how to email. You have to learn to submit PDF. Some people they're used to taking pictures and don't know that, oh, I can submit a picture. You can't submit pictures. You got to submit a PDF. So you can take a bunch of pictures and paste it on a Word document, and then download that Word document as one PDF. For some reason, people want to take pictures, and have 3 pictures for one application, or for three pictures for communication, and want to submit 3 pictures. It only allows you to submit one thing, right? And I think people are just not getting it. So that's a thing that you have to learn to do. If you're doing an online course, you have to learn to do that, okay? Maybe the people here who was on the call, because I think there's 3 people here, 13 people here, you guys are the ones that are fine. It's the other 30 people who are not here, probably the ones that need to hear what I'm saying. But I'm saying it, and the reason I'm saying it is also I'm recording it. So that way people who are not here go watch the recording, understand that they got to learn how to do this, okay? I sent the video many times to different people, and then somehow they still are just trying to They want to blame, oh, Brightspace not working, it's not working, it's not working. Brightspace works. Okay, Brightspace is working. You cannot say something's wrong with Brightspace. You just need help or technical difficulties. If you check in the course outline or in your student handbook, if you get stuck, but I also sent you a video on how to download. But here, if you go in the student handbook, where's student handbook? Here's a student handbook. You click on that, you can find information. The reason why I'm showing you this is because not for you, for the people who are going to watch the video later on. They can watch the recording at the beginning and can catch all this stuff. Okay. So student handbook is right there. Also, if you want to drop the course, it's right here too. Okay. So let's get back into for today. I wasted enough time, so let's get into it. So again, tomorrow is your midterm mark, okay? Whatever you see tomorrow is your midterm mark, and you guys will confirm your midterm mark. Okay, let's get into it. So today's day 12. Okay, so day 12, sorry, August 12th. So here's the video. We're gonna go through graphing properties. So there's two things, graphing properties. And this is properties for exponential functions. And then the other one is a video for transformation. Transformation for exponential functions. Okay, let's go through exponential. Let's go through graphing properties. Okay, here we go.
Here's lesson 4 of the exponential functions unit. In this lesson, I'm just going to show you some properties of exponential functions. We're going to analyze.
Okay, could you guys hear it? Just wanted to make sure before I play. Okay, let's continue.
Analyze a few exponential functions and state properties such as domain, range, intervals of increase and decrease, and asymptotes. Let's start with example 1, where it asks us for all that information for the function y equals 4 times a half to the power of x. In order to state all that information, it would be useful if we figured out what the graph of this function looks like. So let's make a table of values so that we can graph it. For my independent variable x.
Okay, before we even go further, right? You see this here, this equation. Is this an exponential decay or growth? Based on this equation, is it an exponential decay or growth? Anybody? When I look at this, is this an exponential decay or growth? Nobody wants to take a chance? Well, if you guys remember from last week, our A is 4, right? Based on this. Because remember, the general equation is y is equal to A bracket B to the power of x, okay? So A is 4 here, B is a half. So now, is this an exponential decay or growth? Someone help me out now. Anybody? Nobody wants to take a stab at it? Okay. One of the things that I want you guys to understand too, I should have said this before, is that when I do report cards, I do look at initiative, responsibility, all the learning skills that you have on a regular day school. So when I ask questions like this, is an opportunity to also show some of the learning skills. Okay, so I do record this, right? So I'll know who actually participates, and this helps, right? So it helps your marks, right? So again, I'm going to ask you again, is this an exponential decay or growth based on what you see on the screen there? Opportunity to participate and help your marks too. Anybody? Let's see here. All of a sudden, people want to participate. We did no accounts for marks. Growth, 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 decay, decay, decay. Well, remember, this is where we're going to go back into review. Your growth is when your B is, I should have wrote it like this. When your B is greater than 1. When your B is greater than 1, right? When your B is greater than 1, then it's a growth. Okay, so this is growth. When your B is between 0, and I should write it like this, between 0 and 1, I'm actually writing this wrong, right? This is the other way around. Okay, when you're between 0 and 1, then it's decay. Okay, and so the decay looks like, so this is growth, right? That's a growth. Okay, decay looks like it starts a high and it comes down low. Okay, that's decay. So you have to remember that, and maybe you guys just it's a Monday morning, everyone's tired. I get that, but that's a decay and that's a growth. Okay, so when you look back at this is going to be a decay. Okay, so what he's going to do now is going to plot it. Okay, so pick your points for X. He's going to plot it for X. So now he's going to plug in these values for X, right? You start off at -3 because he wants to, make it even, go from -3 to +3. So now he's going to plug in the X value into the equation and basically figure out what is the Y. Okay, for each one. Okay, and to be honest, once you know the first Y, you know the B factor is a half. That means from each amount, it's gonna be, if you multiply by half, it's getting smaller by half, right? So you're multiplying by half. So you don't actually have to plug each one in. You kind of know based on it's an exponential. So if it's 8 now, then it's going to be 4, then it's going to be 2, then it's going to be 1, then it's going to be 0.5, right? That's going to be the last one there, right? So you know that, okay? So when you plot it, you're going to start it from high at -3. It's going to be at 32 up here. And as I get closer to 0, it's getting smaller. And then I go along as I get closer to the x-axis, it's getting really, or when I get closer to the y-axis, it's getting really small. So it's like almost like this asymptote at the x-axis. Okay, so we get really close to the x-axis. So you're gonna see it plotting it. There you go. And really close to the x-axis. Okay. Okay. And that's what you get. Okay. You get a graph that looks like this. Okay. So now we want to find, when you get a graph like that, just like in other functions, just like in the polynomial functions, you can find the domain and range. So now here he wants to find the domain and range. And domain deals with all the numbers, all the restrictions on the x-axis, and range all the restrictions on the y-axis. And then it also wants to find the x-intercept and the y-intercept. Okay, so I'm going to play it from here.
Domain of this function, well, the function will continue forever to the right and also forever to the left, so there are no restrictions on the domain. Algebraically, I could sub anything I want in for x and be able to get a value for y. So the domain, we say x is an element of real numbers. The range, however, notice if we're thinking vertically, where does this function exist? The function is always above 0. It's never below the x-axis. So for the range, we say y can be any real number, given it's greater than 0. The y values of every point on the function are always going to be greater than 0.
The reason why is that there's no value. If you just look at algebraically, oops. Make sure I'm doing this. What's going on here? Okay. The reason why there's an asymptote on the x-axis, or the reason I'm also saying the same thing, the reason why y will never equal to 0 is because there's no value they can put on the x that will make this equation equal to 0. So y is a function of x, right? There's no value you can put in here that will make this whole equation equal to 0. So y will never equal to 0. It'll be really, 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 really small. It'll never equal to 0. Okay. You can also, but you also can find out. So your x-intercept, it will never cross the x-axis. The y-intercept, well, where x is 0, what is y? And I think you already have it up here. So y is 4. So x-intercept is 4. Okay. And then intervals of decreasing or increasing, well, it's decreasing, right? Asymptote is y is equal to 0. Okay. So that's what for this function. I want to play it out so you can hear what he's saying.
X-intercept, well, the function never crosses the x-axis, so we'd say none. But the y-intercept, if I look at my graph, the y-intercept, it crosses the y-axis at 4. Intervals of increase, decrease, well, exponential functions are either always increasing or always decreasing. We define increasing or decreasing based on as x is increasing, what's happening to y. So if I look at my table of values, as the x values are getting bigger, what's happening to the y values? They're getting smaller. And graphically, as the function moves from left to right, is it going down or up? It's going down to the right. So for both of those reasons, we would say this is a decreasing function. It's decreasing over its entire domain. Asymptotes, there is a horizontal asymptote at y equals 0. There's the properties of that function. A couple things I want you to notice. I want you to notice that the
Okay, so the properties of the function is right there. Okay. Domain, any real number for the x. Range, y cannot be less than 0, so y is always greater than 0. X-intercept, none, like I said. And then the y-intercept is written like this, and it's decreasing, and the asymptote is y is equal to 0.
The y-intercept shows up in the equation right there, and that the pattern in consecutive y values is determined by the base of the power. So let's pay attention to those patterns as we continue these questions. Part B is...
Okay, so part B, so it's the same thing, okay? So we're just getting used to these patterns. Part B is the same thing. When you look at it, we're gonna write out our the general formula, so you can remember that. So y is equal to a bracket b to the power of x. Okay. In this case here, our a is equal to -1. Okay. Our b is equal to 3. Okay. Oh, we have this issue here. We have a -x. Ooh, that's good. It's confusing. So, what you want to do, we have to go back to exponent rules, right? Remember exponent rules, right? Let me change my color. I'm going to use A. So exponent rules, right? So I'm going to write it down here, right? Exponent rules. When you, let me not use A, let me use a different number. Let's use Z. I'll use that letter, Z to the power of -2 is the same thing as saying 1 over z to the 2, okay, to the +2, okay? So that's the exponent we really need to use to apply to this -x. So if I rewrite that, right? If I rewrite that, then sorry, I'm just giving myself some space so I can write. If I rewrite that, so let me use, so it should be like this then. Y is equal to, I'm going to have this -3 over here, or this -1, and then this bracket now, someone wants to come in, this bracket, I'm going to have 1 over 3 to the power of x. Okay, +x. Okay, so now that changes things, right? Because now if I write it like that, because of that, my b is now going to be 1 over 3, 1 over 3. So now it changes it and makes it look like it becomes a decay now, okay? Right? The only thing that's now affecting how the graph is going to look now is the -1, right? It's not going to look like a normal decay because of the a is -1, okay? So that's what is going to happen. So let's plot it the way it is. Let's play the video first, so you can also hear that explanation. Okay, here you go.
Is -3 to the -x. Let me actually rewrite that equation a little bit. That negative that you see in front of the 3, right here, is not part of the base of the power. So I'm going to make that clear by writing it as a -1, and then putting the base of the power 3 beside it in brackets. And the exponent is -x. We can actually make the exponent positive. Right now it's negative. I can make it positive if I do the reciprocal of the base. So instead of 3, make the base 1 over 3, and then I can change the exponent to positive. So let me make that adjustment. So that equation is equivalent to what the question gave us, but it's going to help us see the pattern in the properties of this function a lot better. Let's graph this function. Let's choose some x values.
Okay, so now you see he rewrote it. Okay, he wrote it like I showed you over here. Okay, your a is -1, your b now is a third, and your x is there. So now it's easier because now we know, oh, it's a decay, right, by a factor of 1/3. So if I write all my x values here, then I get my first y value, and then my second y value will be multiplied by 0.3 to get it smaller by, sorry, by multiplied by 1/3. Okay, so our first x value we're gonna get, I think he's gonna start. He likes to start off like a little bit of on the negative side, then go over to the positive side. I think he's gonna start off at -3. Let's just fast forward a little bit. Yeah, oh, he started off at -2. So he balances out -2 to +2. So now from the -2, you plug in -2 into x, and you figure out what your y is. Okay, so if I plug in -2 in there, I'm gonna get -9. That means the number after that, going from left to right, is going to be smaller by 1/3. So this next number should be -3, right? There you go, -3. And then the next number should be 1, right? Multiplied by a third. My next number should be 1. Okay, and then so on. Let me clear my other stuff that I have on the screen so it's not confusing. A lot of writing there, right? So there you go. Okay, and so on. I'm gonna play the video from here.
-0.11 approximately. I can plot these points. Let me make my scale on my graph. And now let me plot the 5 points that I have, the first one being -2, -9. Notice this function is also going to have a horizontal asymptote at y equals 0. All exponential functions have that horizontal asymptote.
Okay, So he started off at -9, and then the next one was -3, and so on, and it's going this way, right? Normally, okay, let him finish, then I'll show you something.
At y equals 0, unless we were to shift the function up or down with a c value. So there's a rough sketch.
Okay, so that's the rough sketch of this exponential equation. And now I want to show you something here, right? By drawing this. Put that out of the way. So you see how it's flipped? Normally, for exponential function, it would have started over here. If it was a normal decay. It would have went like this, right? That -1 in front of the function flipped it, right? It flipped it, right? Remember transformations? It flipped it, right? Over the reflection is about the x-axis. So it went from here down to here. So it's now, when you flip it like this with the minus in front of it, it's actually not a decay anymore, right? Because when you think about it, it's a decay in the sense of how it is, but it's really not a decay, because if you look at it, if I'm going from left to right, it's actually growing, right? I start off at a small number, and then I'm actually growing. It's confusing a little bit, but it's because of the -1, it's flipped, so it's actually growing. Okay, it would be a normal decay without that -1 in front of it. Well, without that minus, it would be like a normal decay. But because it's not, there's a minus there, it's flipped, so it's actually increasing. So you have to understand it's actually increasing. But it looks like this. Okay, he's going to mention that. Let's hear that again.
Of the function, let's state the properties of it. The domain of any exponential function is x can be any real number. Right, the function goes forever left and forever right, and also we could sub anything we want in for x into the equation, and we'll get an answer. So the domain, no restrictions, x can be any.
Okay, so there's no restrictions on the domain. Okay, as we know. So that's going to be normal. Okay, the range, there will be a restriction, right? It cannot be greater than y equal to 0. Okay. So let's look at that. Let's write that out. That's the domain. That's the range. Y has to be less than 0. X-intercept, it will not cross. There's none. Y-intercept, yes. When x is 0, y is -1. So it does cross the y-axis at -1, 0 and -1. Now, the part that's going to be confusing is when he gets to intervals, is it increasing or decreasing? And that's what we're talking about, the intervals now. From here to here, is it increasing? And this is the part that you have to understand. Yes, it's increasing. But let me play the video.
X-intercepts, it doesn't have any. The y-intercept, I see it crosses the y-axis there at -1. And then is this an increasing or decreasing function? So as x is increasing, what's happening to these y values? Notice they're getting bigger. And if I look at the graph, as I move from left to right, the function's going up to the right. So that means,
right? I'm going from left to right. It's actually increasing.
it is an increasing function. And the asymptote is still at y equals 0. So once again, the connection I want you to make, notice the y-intercept shows up here in an exponential relationship, and the pattern of what happens to consecutive y values corresponds to the base of the power. Let's move on to example 2, where we'll use that relationship I was just talking about to be able to generate the equation in the form y equals a times b to the power of x for the exponential function that we see here in the diagram. Let me start by actually labeling some points on the graph.
Okay, so now here is the situation where you have to come up with the graph. Okay, you have to come up with the equation. So you have the graph, grab points from the graph. This is going to be on the test, by the way, tomorrow. Right, you're giving the test tomorrow, and it's going to be on the test. Unit 3 test. All this stuff, right? You look at the graph, and then from the graph, you have to come up with the equation, okay? And that's what you're going to be doing. And try to come up with the equation based on the graph. Okay, so let's follow the video.
Graph. So I'm going to label some consecutive points. I don't know what the coordinates are there exactly, but this point looks like it's at 1, 6. This point looks like it's at 218. And this point looks like it's at 354. This is at 0, I'm not sure. But if we look at the pattern in the y values, we could probably figure it out. Like, look at consecutive y values. If we go from right to left, it goes from 54 down to 18 down to 6. It seems to be being multiplied by.
Okay, so what he did here, he's going from 0. He picked consecutive numbers here, right? So you want to kind of do that when you're trying to come up with the equation from the graph. So when you pick consecutive numbers here he picked 0 consecutive x numbers, I should say. 0, 1, 2. Okay. At 0, you can't really tell what that is. It's really small. From 1 to 2, well, it goes from 1, but then went from 6 to 8. So you're trying to figure out how much did it increase by. Okay. So what's the pattern? The thing is that you don't know what, if you knew the first one, then you can tell, okay, maybe it's decreasing by a certain amount. Okay. So let's continue the video. Let's continue with the video.
By a third each time. So if I do 6 times a third, I'm guessing that this next y value is going to be 2. I'm not sure. We'll calculate it algebraically.
So he's thinking it's increasing by a third, right? So let's see.
To be sure. So let me label in this table of values the points that we have. Now, if we're going to be able to write the equation of this function, hopefully you remember from the first couple examples we did, I told you the base of the power corresponds to what is the scale factor that gets us from one y value to the next one. What are we multiplying by to get from 6 to 18? We're multiplying by 3. And that same scale factor stays true for each pair of y values.
Okay, so sorry, I thought it was saying 8, but it's actually 18. So, I misread that. So if I'm going from 6 to 18, I'm multiplying by 3. So therefore, for me to go from whatever value to 6, I have to multiply by 3. Whatever number that would be 2. So 2 times 3 gives you 6, then 6 times 3 gives you 18. So my B is going to be 3, because you can see it's increasing by a multiple of 3. So my B is going to be 3. My A, we'll figure that out now.
Times 3. So what y value did we multiply by 3 to get to 6? Well, like I said, we can multiply it by 6 by a third to figure that out, and it is 2. But let's solve it algebraically to be sure. So into our exponential equation, y equals a times b to the power of x. We know the base of our power is 3 because the y values are repeatedly tripling. So I can say y equals a times 3 to the x. And I can sub in any point that is on my exponential relationship for x and y and then solve for a. Let's pick any of the points in our table.
Okay, so you know what A, you don't know what A is, but you know what the B value is, right? So now for this equation, if you want to solve for A, right, pick any point, right? I can pick 0 and 2, I can pick 1 and 6, I can pick 2 and 8, and plug it into here, okay? Then I can solve for A. Because if I pick 2, I pick this point here, so 2 and 6, that means my x is 2, sorry, 2 and 8. If I plug in my x is 2, my y is 18, I can solve for A. If I plug in 1 and 6, well, my x is 1, my y is 6, I can solve for A. Okay, I can pick any of these points, plug it in here, I can solve for A, because I know what my B is now. Okay?
Where we know x and y, so we might as well just pick the point 1, 6. 6 is the y value, and 1 is the x value.
Okay, so that's what we did. He picked point 1 and 6, plug it in here, you solve now for A, because the B value is already there.
And then if I isolate this equation for A is 6 over 3.
So A, when you do the math, A is 6 over 3, A is going to be 2. So my equation now is going to be, I'm going to fast forward a little bit. There you go. Y is equal to 2 bracket 3 to the power of x.
And our exponent we write as x. That equation defines the relationship between x and y for all points that make up this exponential relationship in the graph. Let's do another example. Example 3 says, a radioactive sample has a half-life, let me highlight that, has a half-life of 3 days. The initial sample is 200 milligrams. Write a function to relate the amount remaining in milligrams to the time in days. Since we want
Okay, so we write the general equation. We know y is equal to a bracket b to the x. Okay, when it says half-life, we know half-life means it's going to be, it means it gets smaller by half. That means our b is equal to a half. Now our a is in this case, we know our a is always our initial value. Our initial value is 200. Okay. And x is in terms of time. Okay, so we're gonna have t over how long it takes to get to half-life. So it's t over 3. It takes 3 days. So my equation now is going to be y is equal to 200 bracket a half, and then our exponent is not x, it's t over 3, right? And we say it's t over 3 because x is equal to your total time divided by the time for the half-life. We don't know the total time yet. We're gonna have to figure out what that is based on what that tells us. But right now, the total time is just t, and it's over 3. So that's our equation. Play the video, and you'll see you'll get to that same value.
to write an x.
Actually, let me see if I can just fast forward a little bit. There you go. So move some of this stuff out of the way. Oops.
A is the initial value, and
Okay, you said A's initial value, like I said.
B is the growth or decay factor. So let's
Okay, so we know that. So when you fast forward, that's what you get, like I wrote down there. And then he's going to talk about time again.
exponent x is how often it gets cut in half. Well, it gets cut in half once every 3 days. So my exponent would be the total amount of time divided by 3 days.
Okay, so that's what I got. Total amount of time divided by 3 days. Okay, so let's continue.
That'll tell me how many times to multiply 200 by a half. And we can actually write this in function notation to make it a little more clear that this is a function of time. We can say the amount at.
So now when you say write in functional notation, instead of having, you just change your y and basically write it as in terms of time, because that's what it is. So you're going to have here the amount as a function, so of t equal to the equation. Okay, so you rewrite it like this. Oops, my bad, too much. I'm gonna go back. I'll play it from here.
At time t equals 200 times a half to the t over 3. In this box here, let's now summarize how we can tell if an exponential function is increasing or decreasing based on the values of a and b in the exponential relationship. So let me write down the 4 different possibilities. Let's start with this one here. What if the initial value of the exponential relationship is bigger than 0? So I'll put a point right here.
So let me just back up a little bit. Okay. And by the way, the previous question, it was a decrease because the initial value was 200 and saying it's decreasing every 3 days. So with this question here, what do you know so far about the function of y is equal to a b to the power of x is increasing and when it's decreasing, right? So we normally know that when you graph like this, that's increasing, right? You normally know that, right? And this is decreasing, right? We know that, right? But then we also learned that if I go from here, even if I go like this, that's also increasing, okay? And also too, if I go like this, let me write another example of something that could be decreasing. If I go from here and I go like that, that's a decrease also, okay? This is a decrease. This is also a decrease because we're saying decrease on the y value. My y value is getting smaller or my y value is getting bigger. So there's multiple ways to show that if the y value is getting smaller, it looks like this, or it also looks like this, okay? When the y value is getting bigger, it looks like this, or it may look like this. It's getting bigger, like that, okay? So there's multiple ways. And when it's not the traditional way is this. Let me see if I can highlight. That's the traditional way. So let me use yellow. So traditional way is this. Okay, that's a decrease, right? That's a traditional decrease. And over here, that's a traditional increase, right? That means my A, and if I write this out here, let me write that out. Over here, use different color. I'll use red. For this one here, A is greater than 0. I'm not talking about the B value. My A is greater than 0, that means it's positive, okay? That means it's positive. Okay? Over here, for this one here, my A for this one is less than 0. That means it's negative. Okay? Now, for these ones down here, I'm going to highlight it and give it a different color. Maybe I'll use red. That's fine. When I highlight these ones here, that is an increase, but my A value, for this one here, it's less than 0. Okay, it's negative. And then for this one over here, I'm gonna highlight the last one. This one here. That one there, my A value is positive. Oops. My A is greater than 0, and it's positive. The problem is it's positive, my A is positive, but my graph is decreasing in value, right? So he's going to talk about that. I wanted you to see that, and hopefully that develops in your mind. And now he's going to talk about, how that the A value could influence your graph from increasing to decreasing, even though your growth factor could be greater than 1, it can still be a decreasing graph. Okay, so now watch. I'm gonna play the video, and I'm probably gonna have to clear it off the screen, but I'll play the video for now.
In the exponential relationship. So let me write down the 4 different possibilities. Let's start with this one here.
See, I already showed you the 4 different possibilities. He's gonna show you again. Okay, so I'm gonna clear my screen so you can see clearly the possibilities again, right? You can see here, A is greater than 0, A is less than 0, and let me clear the screen so you can see the other possibilities. okay? A is greater than 0, A is less than 0, okay? So let's look at each one. I already went through it, he's gonna go through it again.
Here. What if the initial value of the exponential relationship is bigger than 0? So I'll put a point right here. That's where it starts on the y-axis above the x-axis. And the b value is bigger than 1. That means the y values are repeatedly getting multiplied by a number bigger than 1. So as I move to the right, those y values are going to be getting bigger. So the exponential relationship will look like this. Notice it's going.
Okay, so that's a typical one, right? That's a typical, so therefore, and our b is greater than 1, so that's typical, so that's gonna be exponential growth, right? So it's growing, okay? Let's go on to the next one. So you're looking at this one now, right? This one now, right? So it's increasing, but this one now, our A is negative, right? Even though our B is greater than 1, that A, we flips it. So I'm gonna play it from here so you can see what he says. Okay, from here.
Is an increasing function. Let's now focus here. What if a is less than 0, but b is bigger than 1? So that would mean if a is less than 0, we start on the y-axis below the x-axis down here, and that value is going to get multiplied by a number bigger than 1 repeatedly. Let's say a is -2 and the b value is 2. So that -2 is going to be multiplied by 2 repeatedly, so it's going to go from -2 to -4 to -8. Those values, as I go to the right, are getting smaller. So notice this function is going down to the right, which is why this is a decreasing function. Another.
Okay, you can see they just married each other. Okay, it's still, your B is still greater than 1, but then because the A that became negative, it became a decreasing function. Okay, it's a decreasing function. It doesn't mean your B is, it's still not a growth factor, but the fact is the number before that makes it a decreasing exponential function. Okay.
Another thing to notice is that this function is just a vertical reflection of that one. And I should probably sketch in both of these functions have horizontal asymptotes at y = 0. In these two sections, I have the base of the power being between 0 and 1. So that means our initial value is repeatedly being multiplied by something that's going to make it smaller. So if a is bigger than 0, that means we start above the x-axis. And as I move to the right, that value repeatedly gets multiplied by something between 0 and 1, so it's going to make it smaller. So here we have a decreasing function. But if a is less than 0, so it starts below the x-axis, and we repeatedly multiply that by a value between 0 and 1, it actually makes the value bigger because it makes the points go higher. It makes them become closer to 0. So that's an increasing function. And notice that that one is just a vertical reflection of that one. So those are the 4 scenarios. Let's look at some examples where we actually have some numbers and do some rough sketches to figure out if these are increasing or decreasing functions. We won't make a table of values to graph these super accurately. We'll just do a rough sketch.
Okay, so I'm going to fast forward this because we're just graphing and you guys can do the graphing on your own. He's basically doing, when you look at this, he's just graphing our, this one here, this would be exponential decay because your B is at 1/2, okay? And your A is 2. So let's see what he does there. There you go, giving you the formula. Okay, your B is 1/2. Okay, so that's all I do. He's graphing. So I'm just gonna just fast forward a little bit. You can see the graph is complete. It's decreasing. Yes, it's decreasing because you can see that, first of all, it's a decay, and then your A is a positive. Over here, your A is positive, but your B is less than, is greater than 1. So it's going to be an increasing function. Fast forward that. You're going to look at that. There you go. It's increasing. Okay. So we're done with that. We're going to go on to the next video. I think there's only one other video here. So transformation. Yeah, we got to talk about that. But transformation is it's like transformation of functions in general, right? You have the things that make it stretch, compress. You have things that make it move left and right, up and down. So that's what we're going to talk about now. We're going to go through this about another 10 minutes, and then you guys will be done. So give me, because I started late, sorry guys. And I had to talk about a little bit of different things at the beginning. So let's go through this video quickly.
Here's lesson 5, the last lesson of the exponential functions unit. This is on transformations of exponential functions. The goal of this lesson, let me just scroll a little bit, is for you to be able to look at, I'll go to the last question actually, you to be able to look at a exponential function that looks like this. This is a transformed 1/2 to the power of x function. I need you to understand what this -2 that's being multiplied by the power, what this -2 that we're subtracting from the power, and this -3 that we're subtracting from the exponent of the power.
Okay, so this is a transform exponential function, and that's what this lesson is about. Okay, so we've just been plotting regular exponential functions. Now you have transform. Well, normally we only had to worry about the a, okay, if it's positive and negative or the value. But now you have to worry about the x, what's affecting the x up here, and then what's this number over here, how that affects the graph of the exponential function. These are the new things. So let's start.
What those do to transform that 1/2 to the power of x function and actually go ahead and be able to graph that function by applying transformations to the 1/2 to the power of x function. In order to do all of that, I'm going to have to remind you about what the transformation parameters a, k, d, and c do to transform a general function. And even before that, maybe let's do a little bit of a warm-up question where I've given you 7 functions here, and it says which of the following graphs would be the same. In order to do...
Okay. I think we're going to have to skip this warm-up question because I think we're all warmed up, but we're going to have to get into the actual transformation stuff. So let's fast forward. The one thing that I guess you should know, some of the rules, maybe I'll talk about that, the exponential rules, right? Do you remember this exponential rule? X to the a bracket to the power of b means you multiply the exponents. So that is something you should remember. Okay, it may come up, so know that. But we'll fast forward. He's showing you how this is the same as, well, it's the same as this one here. So these two should be similar, right? Because if you apply that, so those two are similar. That's what he's basically showing you. Okay, I'm actually going to fast forward that. You guys can watch that later on, but just showing you the equivalent exponentials. Okay, so let me see if I get there. It's about here.
I could rewrite 3 to the power of 2x as a 3 squared to the power of x, which is 9 to the power of x. So that, of course, is equivalent to the g at x function. Now that we've done a little warm-up, let me remind you about what the parameters c, a, d, and k do to transform a function. And we're going to look specifically at how they transform an exponential function.
Okay, so remember those things transform the function. We did that in the last unit. Okay, so now you're going to do it for the exponential, how it transforms exponential. So here we go.
If we have an exponential function that looks like this, b to the power of x, we can multiply that power by a value, and usually we call that value a. We can add or subtract a number from that power. I will call that value c. And then we could also manipulate its exponent. I could multiply the exponent by a value, we'll call it k, or I could subtract a value from the exponent, I'll call it d.
Okay, so this is all the variables you need to know to transform your exponential function. Your a will stretch it, right? Vertically, like we normally know. A will stretch vertically or compress vertically. Your c will move it up and down. So move up and down vertically. Your d will move it left and right horizontally. And your k will stretch your exponential function horizontally or compress it horizontally, right? And it's always k is the factor to stretch is 1 over k. to stretch and compress is always 1 over k. So whatever my 1 over k is, if my 1 over k gives you a value greater than 1, then it's going to stretch it. If my 1 over k gives me a value of less than 1, then it will compress it, okay?
So that's what a transformed exponential function would look like. I'll call this function g at x. And I'm just showing you how we can manipulate the f at x function by multiplying or adding numbers to the power or to the exponent itself. And let me remind you what those values would do to transform a function. So let's go into Desmos and let's play around with those parameters.
Okay, he's going to go into Desmos. We're going to like kind of fast forward things. Okay. Okay, well, you know what? Let's watch Desmos, because he's doing all of it in here. So let's spend some time watching it in Desmos. Okay, let's go back. Let's watch it in Desmos. Okay, so he has all the parameters there, and this is our normal graph. And then he's going to change our factors, or not our factors, our A or K or D or C, and see how that affects this graph. So let's watch.
C programmed in to be transforming a 2 to the power of x function. A and C do vertical transformations. The C value, which I'll manipulate first, notice moves a function up.
You see that? He moves the C, everything moves up and down. Even the asymptote moved up too, okay?
And down. If C is positive, it moves the function up. If C is negative, it moves the function down. Also, another important note here is that exponential functions have a horizontal asymptote that starts at y equals 0, but as we manipulate the C value, that moves the horizontal asymptote up and down according to the value of C.
So when the question says, what is my asymptote? Then you can just look at, what's my C value? If my C value is 0, well, my asymptote horizontally, y equals 0, right?
A value also does a vertical transformation, but it either vertically stretches or compresses the exponential function. If A is bigger than 1, so like up to 2, notice there's a vertical stretch, all the y values double. But if A is between 0 and 1, so let me make it a half, notice there's a vertical compression. The y values get cut in half. If I make A negative, the same thing happens, it just vertically reflects the function as well. Let me set A back to 1, and let's look at the horizontal transformations k and d. The d value, if I make it positive, that shifts the exponential function to the right. If I make it negative, it shifts it to the left. And the k value does a horizontal stretch or compression. The stretch or compression that happens is based on the reciprocal of the k value. So if I make k 2, it's actually a horizontal compression by a factor of 1 over 2. Notice the x value of any given point gets cut in half. If I make k a half, it's actually a horizontal stretch by 2. The x value of any point is being doubled. And of course, if I make k negative, that does a horizontal reflection across the y-axis. Okay, now that you remember those properties, let's go ahead and try a question. Example 1.
Okay, so those properties, now we're going to look at a question example, okay? So here's a question. It's all transformed. What is the base function? Describe the transformations made on the base function. Okay, so we're going to go through this example right here, okay?
1 says graph the function g at x, which is equal to 2 times 2 to the power of a half times x minus 1. What is the base function? If I zoom in on this, the base function just means what function is being transformed.
What function is being transformed? What's the base function? The base function is, when you rewrite the base function is just basically 2 to the power of x, okay? That's the base function, right? Now that base function is transformed by this 2 over here, by this half that's there, and by this 1 that's over here. It's applying to this base function to make it to stretch it vertically, to stretch it horizontally, because it's a factor of k right there. 1 over k, that makes it a 2, so stretch horizontally, and then to shift it horizontally, okay? So that's what that is. Let's play it out.
So we just look, what is the base of the power here? The base of the power is 2, and the exponent is, of course, x. So our base function is 2 to the power of x. I'll say y equals 2 to the power of x. That's our base function. And then we are going to figure out what transformations are happening to that 2 to the power of x function. There's a number being multiplied in front of the power. We usually call that an a parameter. In the exponent,
Okay, so he's going to talk about the a parameter, right? There's also a b parameter. Sorry, not a b parameter. There's also the k parameter that's there, and there's also a d parameter that's right there. So he's going to go through all the parameters. Let's see here. I'll play the video.
we have a value being multiplied by x, that's k, and we also have a value being subtracted from x, that's d.
Okay, so that's what's happening. Our a is stretching it horizontally, sorry, vertically, right? So when he writes this out, what transformation is being done to the base? He's going to talk about it right now. Let's see if I can fast forward a little bit. Okay, so a, like I said, is a vertical stretch by a factor of 2. So what does that mean? Let's play it out. He's going to show you right there.
So in brackets, I'm going to write what algebraic operation I would need to do.
Okay, so all my y values are being multiplied by 2 now. Okay, now the next thing he'll talk about is our k. Let's play it out. Okay, k is a factor. K is 1 over, k is equal to a half. But then when you apply that, it's going to be by a factor of 1 over a half. So I want to play the video so you understand what I'm saying.
So this is a horizontal stretch by a factor of the reciprocal of the k value. So a horizontal stretch by a factor of 2. So algebraically, to accomplish that, I would
Okay, so the factor is always the reciprocal of k. So if k is a half, that means my factor is 2. That means I'm multiplying by 2. Each x value up here, I'm multiplying by x by 2. Okay. Now I have this 1 there. It's gonna have a horizontal shift. I'm gonna basically, so that's our d value, and our d is 1. So it horizontally shifts to the positive right. So now these are my transformations. When I plot this, sorry, when I do a table of contents, this is my base, not table, but table. When I make a graph, I start off with my base function, get my values for my x and y, and then for my transform function, this is what I'm applying. We did this like in a unit 2 test, so you guys should know this from unit 2 test. Okay, so now that's what's happening for each my y and my x. Okay, so now he's going to have a table. The table here is going to be for, this is going to be our last thing we're going to look at. Okay, we're going to go through this table and then we're going to graph it and then we're done. So we're going to go through this table. So if you graph the table of y is equal to 2x, that's our base function. Okay, that's our x values. Now our y values, plug it in. You get your y values. Okay. So there you go. Going from left to right, it's increasing, right? Exponential increase. Now here's our transform function. So remember, for the x, you multiply by 2 and you're going to add 1. So each of these values for x, I'm going to multiply by 2 and add 1. You're going to write it up there, what it looks like. Right? Yeah. There you go. 2x plus 1, and then all my y values I just multiply by 2. And then from there, I can come up with my new chart. Okay? That's what this means. So every x value, I'm going to multiply by 2 and add 1. My new values for x are going to look like that. Okay? This is from unit 2 test. The only difference is we're not talking about quadratics, we're talking about exponential. There you go. Okay? So now we can graph that. Okay, we're going to graph it. You graph this is the regular function. This is the base function. Okay. Okay. And then he's going to graph the transform function.
Showing it continues in both directions. There's the g(x) function. Example 2. Let's look.
Oops. Did I miss something? Oh, what happened was he just graphed this one. There was nothing moving it up and down, so that's why it just looks like it's that is the function. Okay. He just plotted the points, and that's what he got. Okay. Okay, this function here, this example here, you can see there will be a shift on your y. Okay, so your base function here, let me write that out. Your base function would be y is equal to 3 to the power of x. Okay, that's your base function, right? But then all your other functions or factors, I use my a is, there's no value for a, so my a is equal to 1. My k is right there. My k is equal to 2. My d is equal to 4. Over here, my c is equal to 1. Okay, so with this question here, if that's the case, there's no horizontal, there's no vertical stretch, right? So a is equal to 1. That means nothing's happening to my y value. In a sense, it's not going to stretch, go up, or it's not going to stretch, or it's not going to compress. For my k, as a result of having a k of equal to 2, that means I'm going to have a factor of, it's always 1 over k. Therefore, I'm going to compress, because 1 over k equals to, that's going to equal to 2. Therefore, compression horizontally. So whatever value of x is, I'm going to divide by 2. Okay. My d is equal to 4. That means whatever my x value is, I'm going to add 4. Okay. I'm writing all over the place here, but hopefully you guys can understand that. C is equal to 1. That means my y value, I'm going to add 1 to it. Okay. So in conclusion, let me circle what you need to see here. My y value, I'm going to add 1 to it. My x value, I'm going to add 4 to it. My x value, I'm also going to divide it by 2. My y value, there's nothing I'm not going to multiply anything to it. It's going to be the same. The only thing that's going to affect the y is going to be down over here. Okay. So these are my transformations: x plus 4, and then x divided by 2. Each value for x, I'm going to divide it by 2, and I'm going to add 4. For my y, the only thing I'm going to do is I'm going to add 1 to it. Okay, so that would be your transformation for this function. Let me fast forward it so you can see the final answer for that. There's stuff on the screen here, so I'm going to have to clear the screen so you can see it. So let me clear the screen. Maybe I won't clear everything because I want you to see. You know what? I'll clear the screen. It gets a little bit messy. But we talked about this anyways. There's your K, there's your D. Oh, the one thing that you wanted to do, I didn't mention, is you can factor out the 2. So that's what you did there. So that's actually a good thing. You factor out the 2, so your D now is, I said your K is 2 there. Your K is still 2. But then also too, you have to also look at your D is factored out. So it looks like this. Okay. So it should look like that. So I didn't actually show you that there, but that's how it's supposed to be. Okay. So now your D is now going to be 2 instead of 4, like I said before. So that was a little bit of a mistake there, but your K is still 2. Let's fast forward a little bit. So that's your base function, like I said, and your transformation. These are your transformations. And like I said, x divided by 2. Okay. Your d, you're going to add 2, and your y, you're going to add 1. That's your transformation right there. That's it. Okay. And then you plot each one, and then you do the graph. So I'm going to stop there because I'm going a little bit long for you guys. Okay. So that is the end of today's lesson. I'm going to stop sharing my screen. But before I go, I'm going to go back to the beginning. Tomorrow morning, you're going to see report card. Okay. It's going to include whatever the Unit 1 test, Unit 2 test. Okay. Tomorrow is going to be show you report card, midterm marks. Not like, I mean, your midterm mark. It's not your final. So some people are going to be like, oh my God, my mark is too low. It's your midterm. It's not the final. Okay. So don't worry. The final mark can still go up. It also can still go down. Okay. So for today, you have the worksheets to get prepared. Here's the quiz for today's lessons. Okay. And here's the practice quiz for overall. Okay. So that is it, guys. I'm going to stop sharing my screen. That was a long session, I know. So hopefully you guys have a good rest of the day and get ready for the test tomorrow. It starts at midnight. You have access to it at midnight, okay? Okay, guys. Bye.